Hey there. Today we continue with Lumina, um, and basically, what I did yesterday was to clean things up a bit and actually make it work as I wanted to. And I also I managed to make the main run properly and do the auto dependency injection. It turned out that I clicked the wrong link, and that's why the browser showed an issue. But everything was okay. Um, and I also introduced an integration test harness. And because I'm using lit, things are a bit different. Like we don't have React testing library. We have OpenWC. That's something I haven't used yet. And we are using OpenWC, Open Web Components. Maybe I guess that's the testing library for web components. It basically renders, and then we use query selectors and expectations on them to assert things about our code. It doesn't look so bad, and I actually enjoy it. I enjoy the low level nature of things, and the AI writes it, so it's quite good. And what I also loved about it is how fast the tests are. So here are the UI tests. You see they already passed. So these are the unit tests, and these are the um, component tests. And I can test the tests in a really easy manner. So I delete this and the test run, and I see the result in like 90 milliseconds, which is insane for me. I mean, I've been writing integration tests with React Testing Library and React, and I have never seen something so fast. There, probably I'm not doing something right in the context of React, but here it's like blazing fast. I can do whatever change I want, and I receive instant feedback, which is really important for me and my flow of work. So that was something really great. But now we should get more practical. I was thinking yesterday, I'll continue with the test-driven approach, but first I thought, well, we're currently in a stage where we don't know how things are going to work. We don't know what's a development flow that would be useful. And I really want to experiment today with several different concepts. I have no idea about these concepts yet, but maybe I'll start writing them here. I'll do this in actually outside of Lumina. I'll do it in the main directory here because this is just an implementation of the moldable editor. And I'd argue that this isn't the important part of the work we do here. The important part, and is the idea. And given AI, the realization is simple as long as we follow adequate engineering principles. So that's tightly related to spec-driven development, but I take it a step further by like specifying the idea in MD files that are independent of the project. However, I will closely rely on tests to be the executable specification of this um, project. And probably people in the um, formal proofs field will argue that tests aren't an executable specification because, well, they don't exhaust the the space of possible states of the project. However, in this case, I think using like for formal provers and so on, it's an overkill for this. So yeah, so I'll start with the specs, and probably I'll create a new directory called specs, and I'll create a new. I have an empty file. That's strange, but okay, I'll just create a separate file, and I'll say I'll prefix it with one, and let's say it's ideas for key usage. That's I don't think that's the best name, but it's something that I enjoy. So what's this? So we have an editor, development environment. Okay, we have that. And when you are in a moldable development environment, or actually when you are developing a system, a software system, you have to have some tools to develop it. And I'll put that some here so you can see everything. The purpose of a moldable development environment is to make the creation of such tools cheap. Because at the moment, if I want to, let's say, take WebStorm and create a plugin, I'll have to see how plugins are created in WebStorm. I'll have to see what I can do, what I can't. There's some learning curve, and probably it's not so easy. I've never created plugins in WebStorm. But even if I can create plugins in WebStorm, you see the plugins have really specific places. But I want the whole environment to be moldable to the problem at hand. So that's key, and that's what and the creation of tools should be a first class citizen of the moldable development environment, because here you have to go through some hoops, and WebStorm's code, I think it's closed source as well. So tool creation should be a first class citizen. So this might start to actually replace at one point the README, because these guiding principles are LLM generated. I just wanted to have something as a starter, but I don't like them. So probably we'll change this. Okay, so yeah, that's the first thing. Tool creation should be a first class citizen. That's the first problem, one of the problems we have to solve. How we make, and it's mostly about a user interface. How we make a user interface that makes it delightful and easy to make tools so you can understand the problem you're solving better. So so actually I'll write this, how we can make a UI that makes it delightful and easy to create tools which help you to solve a specific problem. So that's one of the things. Next thing is, of course, we still have to edit the code we have. I don't believe we're anywhere close to an age where we'll be able to just use the specs and ignore the code. We'll still be engineers. And engineering is to have a method with which you build in quality inside your product. So the best method I found is test-driven development. But there might be other ways to do that. I mean, so the next important thing for this environment is for an engineer to be able, and it's engineering. So I imagine we'll create a platform where we hardly touch code, be it through having good integration with an LLM or manipulating the code in some other way. However, I don't expect this to be for non-engineers. It will still require our skills. So the next important thing for this environment is for an engineer to be able to change the system on which they work. So this should be either through an LLM or some other AI, manipulating abstract syntax trees, manipulating non-code, non-text representations of the system, or in the extreme case, writing code. So writing code should be the last resort. We have to find an UI that makes this process delightful and easy. So that's it here. And do we have some other ideas for key usage? Like, we want to, first of all, we believe most of the work we spend working on a given system is in understanding this system. So first of all, we should solve the problem of understanding. So even if Lumina doesn't allow code editing yet, and I should do it outside of Lumina, if I can if it helps me understand the system easy, then it's already a win for me. And then the next thing is to be able to change the system from within Lumina. And the last thing that's kind of tangent to it, or I don't know, probably it's always also foundational. I believe Lumina should provide an AI first workflow. So because let's say the overarching workflow. I don't know if I can say something like that, but should be AI first. What does this mean? I don't know. We can have a prompt besides the editor, and then the editor to make reviews. We can have something else. Let's see. At the moment, what I see is that all of our editors and existing AI enabled editors, let's say, are hmm, they are using old processes for making for let's say using AI. Like we still have the diff window, we still have the text input. We kind of adapt LLM usage to what we are used to. But I'm speculating that there might be a workflow that's way better when you're doing AI. For example, one of my speculations is that we can manipulate abstract syntax trees. I don't know how this would look like, just like ideas. We have to verify them. So, and I think I'm talking too much, so let's start with ideas to verify. Use manipulate abstract syntax trees instead of code. The second idea is explore tool creation within Lumina. This should be quite big. I mean, yeah, like lots of ideas there. So maybe we'll start with that. I'm actually more interested in exploring the tool creation. So I'll do commit and let's start with I'll do my repo mix here. So repo mix, if you don't know, it's a nice command line tool that packs your repository in an XML, which then you can feed into an agent. And right now I'm not using an like Cloud Code or something, basically because of pricing. So we have Lumina, and I want to test different UIs that will allow tool creation within Lumina. Let's brainstorm ideas. Let's add a persona. You are an expert technical UX designer. Because I believe like we are not creating something new here in terms of technology. Glamorous Toolkit already has these things, it already allows you. But Glamorous Toolkit in terms of UX, at least for me, it's really hard to understand, and I have to invest a lot of time to understand it. So that's why we're starting with the design in mind. I think this will be key, the developer experience actually. Dev X designer. I want to test different UIs that will allow tool creation within Lumina. Let's brainstorm ideas. Okay, it knows what app I have. Inline command palette. So VS Code style command palette that appears over your content. User hits a hotkey, floating input appears without complete, type natural, show preview of generated tool structure before creation. Okay, so that's interesting. So yeah, another thing I found hard about Glamor's toolkit is that I don't know from where to begin. Like I want to start visual. Actually, I know from where to begin. I can't write the code because I don't know the language. So um, this AI first workflow seems quite cool. Like I can just select a place in Lumina and I can type something. I can type a natural language query and it will generate the tool for me. Or it will start working with me to generate the tool, which makes me think. And I'll stop the screen sharing for a bit just to open the mirror board for Lumina, and I I'd like to draw something. So I'll create space Lumina, and inside this space, okay, so I will, yeah, okay, inside this space I will create what is it, a board, okay, a mirror board, great, and I'll name it UI iterations, or I don't know, and now share again. So okay, so can I hide this? Great, and I'll do it right now. So now so I imagine in this first thing here, inline command palette, we'll have, oh wow, that's cool. I like Miro. I like Miro. I don't know why people still use different tools than Miro. But okay, so inline command palette. Or actually that's the whole UI, a base UI. So I imagine wireframes. Oh, that's cool. Let's see. Rectangle heading. Oh, that's cool. Okay, so I'll add a simple rectangle. And I think we should have two important things here. First, an index for tools, because you have to be able to find existing tools if you want. So for now, tools will be static. So in Glamor's toolkit, what you have is that tools are pretty inline. So let's go here, the game. And I want to show you how it looks like. This is a game that they create here. And as you can see, I wanted to find the maybe the case. Okay, great. So yeah, this is a simple game that they develop here, and the cool things, the really cool thing in Glamor's toolkit is that tools, you can invoke tools whenever you are. So you click here, you see this code, you can execute it, or you can invoke another tool that shows you the class right here in the UI. And yeah, there are some, and if you want to create a new tool, you just start typing, like you create a var code and start typing the code. We're far from there, but I believe. But another thing they have is the spotter. So spotter is the way you find anything within the platform. You find tools. You find um, um, examples, text. I can. Mondrian is their really cool graph environment for writing graphs. So these are all the tools they have here. I imagine we should at first we should start have something like that. Maybe even just a list of tools that you can search and use. And later on it can become more complicated or like more richer. And we have Mondrian, we have examples, another thing I really like. So I can click on whichever example I like, and I can execute it, and it will render a graph. And you see, the other cool thing is everything is clickable. I can click this graph node, and I can explore it right here. And I have different views. Each of these views is a tool in itself, and the things within the view as well. So I really like that recursive nature, and I can no, I can't click 4, but yeah, I can click on this byte array, and I see. You see, I can visualize this array in so many different ways, so I can understand it from different viewpoints. Uh, so yeah, and I can get like a more complicated example. Probably you see, I can click on this, and I see, why it's a small integer. I don't know, but I can click on. That's strange. I thought when I click here, I'll see the node itself, but anyway. So that's what it means to have context-specific tools. So you're in a view, for example, your code renders a React component that lets you uh, that lets you uh, type in your name or to, I don't know, search for some information. And right now you just see it. You see the React component, and you have the code separately. But what I imagine is that in, let's say, in our dev mode, we'll be able to click on that form and actually see only different representations of this form underneath. Like we could see the React component, then we can see the rendered HTML, then we could see, for example, how the data that comes to it, like what comes into the form, what goes out, and we'll have a language with which to develop this. So yeah, and I want to start with such a UI, but it will be really simple. I imagine will have a big input here, probably a page, which accepts text for now. And we will, how can I add? And here we'll have another text box or input. Okay, I'll just create a simple input that will let me search for tools, search tools. And of course it will be like that, and I'll make it not so great. So we have this, and maybe dark gray, yeah. So like a placeholder. So here you search tools and you see a drop down of existing tools, and here you create new tools. So this is a simple UI. Here we create the tools. It will be a really simple editor. I could have an editor code block. Okay, great. We have a code block, so we can see something. What? That's really strange behavior. I don't enjoy this code block. Okay. Okay, but I'll just type code editor. And this, as I think of it, this kind of conflicts with the fact that we want to get outside of the text, but for now it's I think just for the prototyping it's okay. And then we have this base UI and we have the first iteration. So inline command palette. So we okay. So we have the inline command palette here. And how it will look like is basically I click on the code editor with the mouse, pointer, so click somewhere and then it suggests and it opens a text box, or let's try the code editor again. The code. And we type something here. Create a tool that visualizes my classes something. So we have it here. So I will. No, I don't want to try mirror prototypes. Yeah. Okay, just put it here. So that would be the first thing. And I really like GT's notebook-like interface. So I'll probably add this as well. Like you have text and you have two snippets. So yeah. Then the next is conversational panel. So this is what we have right now with most AI-enabled tools. So we have a chat-like interface to the side, and we chat with it, and it's interesting. So it evolves the tool in real time, and it's like not text first. So we have it here, conversational tool creation. So here I imagine instead of a code editor, we'll have conversation with an AI. So we'll have just copy paste this here. We'll have a conversation here. and it will guide everything. So I'll add the text and make it a bit bigger. Through the conversation, you guide the tool creation. The LLM or the AI, let's be more generic, shows you different iterations of the tool with their results and source. That's interesting. I think we should probably dive deeper into this concept as well. So that's another quite interesting approach, I'd say. And then we have Visual Flow Builder, node-based interface for composing tool logic. So we have nodes representing actions. We connect them visually and generate code from the visual representations. And it might be more complex, but here I definitely imagine Zapier or NA10. So Zapier flows. Let me add something that's this one. Let's see. Okay, Visual Flow Builder. Create all these arrows. Because it's more pleasing to the eye. What else we have? Contextual quick action, which is what I showed you. It's kind of what I showed you in Glamor's toolkit, but it invites you to create a tool. So I imagine it can be like I go here, I click here, maybe create a tool, or I click here and maybe it says like create a tool or use a tool. And it kind of knows what to do based on the file. And like I'm dealing with source code mostly. Like that would be my first use case. So what we can do with the source code is basically show different relationships. Like here in index.html, the first thing I can do is just preview it. The other thing I can do is let's say this is too simple, but maybe in the project 3 lister or in this component here, like I can try to render it somehow. Another thing I can do is to like create a representation that shows me what state variables it has, what properties. Like probably Lit already has this, but yeah, just for the sake of it. Or another thing I can do is like I take this component and I can step through it. So this might be quite cool to debug stuff. Like we have Vault 3 here. Get project 3 use case. Yeah, this is actually this render and render node. And I can step through each iteration. That's another tool I can probably do, and it will be quite interesting. But that seems like more complicated for now. Let's see what other stuff does. So we have contextual, two actions, template gallery plus customization. We have two templates, but that's on a later stage. So what it suggests is that I add a context menu, and the flow is you create a tool, you type find all exported functions. State management. Yeah, the contextual is interesting, actually. Because you have to start from somewhere. Another option that I see is in, again, coming from the source, and it's in this graphic. So why is the expanded so yeah, great. So why is moldable development important? We have business and engineering. We have to make a decision at each stage of our work. And for this, um, for example, there's some small part of the system. And we ask the question, why is this piece of the system small? And the old approach without contextual tools is, well, you have gut feeling, uh, you do the assessment on gut feeling, or uh, even if you, yeah, you do the assessment on gut feeling. Why? Probably it's because this. And then you explore it in an ad hoc manner. You find a profiler, or you just look at the code with your eyes, and so on. And you provide some data that you've extracted in a manual way. Maybe with performance, it's not so like ad hoc, because you can use the profiler data, but probably many people won't do that. And then you generate this manually, like run the profiler, you copy paste this, show it, and so on. However, in moldable development, we want to uh, make things follow engineering principles more closely. So we create hypotheses, and we want to disprove each of these hypotheses in order to reach to the truth. And then we export them through moldable tools. Um, so actually, from where? Why did I start talking about this? Probably because of the context. Yeah. So, no, that's another approach. So, and then we explore them to model tools and so on and so forth. And then we ask more questions. So everything begins with questions about the system. So I'm thinking maybe another approach for this system, as I see it, is to have a question answer interface. because at the moment in moldable development we have the so-called role of a facilitator. Moldable development roles. So this one. Well, we have a stakeholder who makes hypotheses. This could be a business owner or the developer. And we have the facilitator who creates the tools and then interprets the results and then leaves it to the stakeholder. This could be the same person. So, but maybe if we start with the question and do a question-based interface, a textual interface, this will will delegate some of the facilitation to an AI. So another interesting concept that I can think of right now is, what if we don't have a code editor here? Why can't I move this? What? Mirror is being strange today. Okay, anyway, so we have a code editor. We don't use a code editor, but instead we rely. Oh, I see I have a new viewer. Wow, welcome. That's great. My first viewer. Say hi to the chat, and um, and they left. So yeah, we have instead of a code editor, we have QA interface. So we have a chat-based interface that's, I ask a question, I make a hypothesis. Let's say, why is part of X of the system swole? Or actually, let's make something that's closer to to the issues I face. How can I implement feature X? So that's the question. And then it answers it in some way. So maybe actually the answer might need to be more let's say because in moldable development you also have the questions and answers should be quite specific in order for them to be meaningful. So and these are they have characteristics. Questions have characteristics, and the characteristics. So that's a moldable development flow. Why are our services slow? And we go through questions and answers until we get more and more specific. Is there useless data? And maybe how is this data traversing the pipeline? So we create a tool that shows the data traversing the pipeline. And we see how one attribute is traveling to the pipeline. Maybe we get to the core of the question. So each question that's asked either generates a human-based answer, as I understand, or a conceptual answer, which guides the next question. Or if we are at a good stage, it generates a tool that provides the answer. So is there usage data generated can create like as I see it here, at the end we are led to a question that shows a specific attribute which generates a view that answers specifically that question through data and not in an ad hoc manner. So yeah, and I can't see the answers. Decision making, the speed of the swoop. So this is like critical. Decision making should follow a scientific method like WOOP involving hypothesis formation, exploration, assessment, and refinement. And the speed of this swoop is crucial for effective decision making. Yet traditional metrics often overlook the time taken to formulate and answer questions, so we want to shorten this time. Answers should be accurate, explainable, and representative, while questions need to be actionable, specific, and timely. These characteristics ensure that the decision-making process is both efficient and effective. So that's the important thing about the question and answer loop. So what if we embed this question answer loop and we can inside the moldable development environment? So we have here the question characteristic. So a question should be actionable, specific, and timely. And the answers themselves should be accurate, explainable, and representative. So the AI is bad at being accurate. We already know this due to hallucinations or whatnot. And the person, the stakeholder, the engineer, or the business guy provides a question like, what is an actionable question? How can I implement feature X? It's specific. Like we have to be more specific about the feature. It's timely because probably I need this feature now. And it's actionable because I want to provide this feature. And then the AI can definitely provide an explainable answer. AIs are good at explaining. However, the AI is not accurate nor representative. And in here, representative to what is being discussed. For example, Alice presents an architectural diagram that Bill has created for a system. The architectural diagram might be accurate about what Bill believes it is explainable, but it might not actually represent the system as being discussed. So AI is bad at this and this. It's good at explanations. So let's add an icon to denote this. So AI is good at explanations, but it's not accurate. AI won't be accurate as it hallucinates and won't be representative, won't provide a representative, won't provide an answer representative of the system as it hallucinates. So, however, we can fix these, or we can partially fix these issues by letting the AI create the tool that we need to answer our question. So let's create sticky note. We can fix these issues by demanding a tool from the AI to answer the question. Or to guide us towards other questions. So it might not be always possible to create a tool right away. Like some questions are pretty high level, like how can I implement feature X? Um, the AI can tell me you should do this, that, but we would be according to the architecture we have. Does it have to have refactoring? How should it be refactored? How should we test it? These are other questions that you should answer before you do the explanation. At least that's how it seems. So it and also it will represent some code. It will generate code and places where this feature should reside. But I have to see them for myself, and I have to see their representations in order to be sure that the answer is accurate and representative. So let's say it answers, you should implement it by modifying components X, let's say A, B, and C. And then, I mean, of course, the flow will usually be faster because the AI will answer way faster. And then my question is, how should I modify component A? And so on and so forth. Like, and here we are talking about a user that doesn't understand the system yet, because probably if you have experience in the system, or the system is small, and you know it, you won't need to ask this question. Probably you ask a question about like to challenge your assumptions or something like, or of course you need to find the file that you have to edit. So even if you know the system, you still have to find the file. So let's say this is a question answer UI. So yeah. Okay, let's pause here. It's been an hour. I'll just end the stream for now, and we'll come back a bit later to continue.